Hey, everybody, and welcome back to another episode of Adventures in Machine Learning. This week, we have a couple of new panelists, so I'm going to go ahead and introduce them, and then I'll introduce our guest, and we'll start talking about our topic for the week. Our first new panelist is Francois Bertrand. Francois, do you want to introduce yourself again? Let people remember who you are, what you're famous for, all that good stuff.
Sure. Yeah, my main claim to fame is the creating the SuiteViz EDA data, exploratory data analysis library as open source. I'm a big fan of data visualization in all its forms. I did a virtual reality data visualization system, all that good stuff. So that's where I'm approaching this from.
Good deal. We also have Ben Wilson. Ben, do you want to just remind people who you are?
Sure. Yeah, hi, I'm Ben, author of Machine Learning in Action, a Manning book, and also the creator of the Databricks AutoML toolkit.
Awesome. I'm Charles Max Wood from devchat.tv, and we have a special guest this week that is Serhii Maksymenko. I hope I got close.
It was pretty close, yeah.
And yeah, we're going to talk about serial video processing with AI. And it looks like from the article, you did a lot of this in the cloud, if I read the article correctly. Some of this, I'll admit, was a little bit over my head, so I'll probably just ask all the stupid questions, and then Ben and Francois can sound smart by comparison.
When I went freelance, I was still only a few years into my development career. My first contract, I was paid $60 an hour. Due to feedback from my friends, I raised it to $120 an hour on the next contract. And due to the podcasts I was involved in and the screencasts I had made in the past, I started getting calls from people I'd never even heard of who wanted me to do development work for them because I had done that kind of work or talked about or demonstrated that kind of work in the videos and podcasts that I was making. Within a year, I was able to more than double my freelancing rates, and I had more work than I could handle. If you're thinking about freelancing or have a profitable but not busy or fulfilling freelance practice, let me show you how to do it in my Dev Heroes Accelerator. Dev Heroes aren't just people who devs admire, they're also people who deliver for clients who know, like, and trust them. Let me help you double your income and fill your slowdowns. You can learn more at devheroesaccelerator.com.
Do you want to kind of give us the 10,000 foot view as far as like what problem you were trying to solve, and then we can kind of break things down from there?
Yeah, of course. So I will try to briefly describe how I see the problem of video processing nowadays. So on one hand, video data is definitely a massive and essential part of the global data, and it is commonly used in many aspects of business and personal life. And on the other hand, machine learning and deep learning solutions show good results with visual data, which is proven in many tasks such as image classification, face detection, recognition, object detection, and so on. And many deep learning models are applied for a video stream as well. And additionally, at the same time, we have different devices which allow parallel processing in a certain form, which are also rapidly developing at the moment, starting from CPU with multiple cores, GPU, the latest versions from NVIDIA, and ending with specialized neural inference boards for neural inference on the edge. So, for example, Intel Myriad, Google TPU, Jetson Nano, and etc. And all this together creates an interest in making some, let's call it, fancy stuff with the video stream, whether to introduce new features and get advantage of the market, or optimize an existing business workflow, or maybe improve security, etc. However, it is not a trivial task because this fancy stuff usually consists of time-consuming operations, and video throughput won't meet the expectations unless additional effort is done for optimization of this algorithm. And well, stuff is not fancy when it is slow. So therefore, the problem which many engineers are trying to solve, and which we will, I hope, briefly discuss today in particular, is how to build fast and accurate enough video processing system which would be able to run cutting-edge AI technologies and use hardware environment in an efficient way.
That makes sense. I guess we should back up a little bit. I usually let the guests introduce themselves, but I was excited to get into the topic. What's your background and how does that play into this?
Yeah, so I am a software development engineer for more than 10 years. And I have been working with data science projects for the last 4 years. And mostly these projects were focused on computer vision solutions. However, I used to be an iOS developer before. So my career started at mobile dev company in 2011 with developing mobile application. And that was fun at that time. Mobile development was cutting edge technology at the time. And a bit later, it became quite easy to integrate computer vision models into mobile applications. So that's why I got interested in the machine learning field. And after I developed an image processing application with the help of DLeap and OpenCV libraries, I decided to switch to it. And since then, I participated in several deep learning projects, and the last couple of them were related to the video processing and to the topic of our current podcast. And I'm excited to be here and talk about it.
Nice. I'm curious if either of our other panelists have done much with video processing or things like this.
Yeah, my main background is actually from video games. I did a fair amount of graphics programming, hence my VR visualization, other visualizations. And I know how video can be extremely finicky. I saw in your paper, you talk about FFmpeg and all these things, and there's these can be pretty painful to work with. There's keyframes. You can't just split videos arbitrarily, and I could see how that could be challenging. So I'm really curious to hear more about how you're managing. Yeah, it's a large amount of data. It's you can't just cut it any which way. So that should be pretty interesting.
Yeah, for me, I've done a handful of projects, worked with customers at my current company, Databricks, who are doing more image processing, not so much video. When they're processing videos, they're usually chunking it up and looking for specific frames that don't have a lot of movement in them, and then just doing image classification on that. Everything from object detection to just general classification. I have a lot of questions for you later on with regards to tips and tricks, and just to hear your perspective on things.
One thing I wanted to ask really quickly, going back to what you were saying before, you mentioned cloud computing versus edge computing. Is that just like a machine in my hands or on my desk versus a machine in the cloud?
Yeah, so basically cloud computing is the architecture where you have a connectivity to some resources on the server, and the main part of the processing is done there. And edge computing is architecture which is kind of opposite, when the main part of processing happens on the edge devices. So it can be, mobile devices is also edge devices, but it can be a special model, something more specialized. For example, special cameras installed in some manufacturing buildings. It can be surveillance cameras, maybe
Okay.
some processing units which handle data from sensors and so on.
Okay.
And in my opinion, when we talk about cloud computing versus edge computing, first thing which we need to pay attention to is scalability. So we definitely can create this connectivity with cloud services, build infrastructure of computing instances, allocate GPUs there, somehow share it between several workers, and manage everything with Kubernetes or something like that. Video card NVIDIA A100 supports virtualization, and it can be split into multiple GPUs. So, and it is very, it may help a lot with cloud infrastructure. But how easy will it be to scale it when the number of users rises? How many GPU will we need, and how much will it cost at the end of the day? And from this perspective, edge computing can be a better option. Well, of course, such decision depends on the goal and available resources. But in my opinion, if we know that we can run some part of the algorithm or entire algorithm on the edge, we very likely need to do it. And with this, the scalability problem becomes much more easy to solve.
I gotcha. Yeah, I just wanted to clarify the terms before Ben asked you his million questions, because I want to hear what he wanted to ask. But we kind of got going, and I was like, okay, first I need to know what your background is. And then I was like, And now I want to know what you mean by edge and cloud. So I think we got that answered. Ben, why don't you go ahead and ask some of your questions? Because I'm kind of curious to see, what you've run into with some of this.
Yeah, I'd start with the elephant in the room. The question that I ask anybody who has specialty in ML, particularly in esoteric ML, which image classification, computer vision is a subset of machine learning and AI, and it's hard, like really hard. So my first question is, if somebody's never done it before and they're looking to get started in it, they have an approved business use case, they know that they need to do something with images. What's your top 3 pieces of advice to tell somebody getting into this? Here's what you should think about before you start.
Well, the first thing which comes to my mind after a question is so-called CRISP-DM methodology, which splits the data science project's development cycle into stages. So first stage is business understanding, and next stage is data understanding, then modeling and evaluation. Probably I missed some stages, but that's in general how it works. So when you have idea in your mind, you need to think about the value which it can bring. And from that perspective, you will get understanding what kind of data do you need and where to get it. So, and I think that in all the stages, data understanding is maybe the most important part, because creating a model, trying some hyperparameters, changing a model architecture, it's not so difficult, but much more difficult is to clean the data, find a way where to find it, gather, and ensure that this data will match the environment where this model will be used after it is done. And so at the first stage, I would pay attention to the question of data. And so if you got a data set with images, the next point is selecting a model. And here, again, you need to ask yourself some set of questions. So for example, where this model is supposed to run. So if you are going to run it somewhere on edge infrastructure, let's say you bought a Raspberry Pi and you want to do some OpenCV stuff with it, then of course you need to select a lightweight architecture which can meet your expectation in terms of performance. If your goal is to run it somewhere on the cloud, probably it can be some bigger model which can give you better accuracy. Yeah, but anyway, first steps will be done not on the edge and not on the cloud, but on your local machine, let's say in Jupyter Notebook, with all the data analysis and evaluation metrics.
Okay, so punching back to the modeling, I've had discussions with people before who are new to this, and they read a couple of blog posts, they get really excited, like, wow, we can feed images and it can detect stop signs and buses and traffic lights, and they're looking at the Uber data sets, of course, and they're seeing how these models perform, like looking at mask RCNN and saying, wow, that's super cool. We can totally apply this to our use case in our business. They may or may not have well-labeled data and masked data with the coordinates bounding boxes to detect stuff. But the question that I get a lot, and sometimes I see people try to implement, is doing a roll your own CNN from scratch. So what are your opinions on building something from the ground up? What are the risks with that versus doing something like transfer learning?
That's a good question. I was thinking about the same stuff, and currently I see a tendency that many data scientists or computer vision experts, they are start looking for some papers, ready-made solutions, find some models on GitHub and so on. And personally, I do not like this way of approaching the problem, because in my opinion, it is better to create a model in your head first, understand how it should work, and then probably if some ready-made pre-trained model fits what you think about it, then you can take it. But otherwise, you can try building it from scratch, and a big chance that it will work in much more efficient way, because first of all, you can pre-trained available models. They are usually trained on common data sets which are
generalized. Right?
Yeah, they're generalized, and they are maybe not so good for your particular task. And by creating your own model and with your own data set, the accuracy will be much better.
Yeah, I mean, I couldn't agree more. And with respect to transfer learning, not so much just use the fully trained model, but saying, hey, I'm going to lock down the first 50% or 60% of the CNN and say, don't relearn this stuff, but I want to use what you've learned here, like edge boundaries, shapes, general characteristics of the image. And you can freeze that and actually materialize what that vector is or what that matrix is at that particular point. You can pool it, get an image and say, oh, it's detecting the outline of things. That's cool. It doesn't know anything about what that is because the classifier stages and the fine resolution is much later on in the CNN. But doing that can save you a lot of time, even though you're not using that model, but you're using how that model learns to detect things of importance in images in general. And then those last stages, you can say, all right, you need to retrain on my images and my labels and learn this stuff. But yeah, I really liked your answer and how you approach it with like, hey, think about what this is doing and what your domain space is. I think that makes it much more successful instead of just picking something from the ether and saying, well, it can detect cats and dogs really well. It should work for my use case. It's like, no, it doesn't really work that way.
So do you think actually that's a good question as far as a particular use case versus generalized data? I guess it's about balancing, maybe getting the benefit from, like you said, the basic shape recognitions, and then figuring out where you plug in your domain specific data. So are you saying that would probably be a good approach to kind of use generalized data for the more common problems and then put in your own model and training data on top of that?
Yeah, I mean, for applications that I've done and worked on, if people are trying to do something similar to like what Pinterest does, right? Their image recognition of general things that people are taking pictures of in the world. Some of these pre-trained models, they're designed to do that. They were trained on that sort of data, and they're trying to say, is this a picture of a lighthouse or a ship or a banana? It kind of does that. You might not use their labels. You have your own labels, so you can lock in the first 90% of that and say, retrain the last 10% of it and learn my labels. And here's all of my training data. So just retrain yourself on mine, but don't manipulate all those early for ResNet or VGG. When you're looking at those extremely deep models, don't retrain how it figures out how to do edge detection. You'll be running a training process for weeks, probably. Inception V3, how many months did it take that to train originally on how many billions of images? You're never going to get the performance with the budget that most companies have versus like Google and Yahoo and how they built those things. Yeah, and it's exactly what I agree with what Serhii said, which is think about your problem statement and what you're trying to solve and adjust it accordingly.
Great. Yeah, because when you said starting from scratch is a good angle, I just wanted to clarify that you're not talking about, like you said, like, reinvent the wheel or start from ground zero. It's really kind of putting, where it matters, your domain specific training on top of those existing bases.
Yeah, one thing that I was wondering was, are there kind of common approaches or common setups, common algorithms, common ways of doing this that you would commonly say, okay, my problem fits well on one of these 3-4 ways of doing it, or I do have to go reinvent it, right? Because, yeah, it sounded like, and you can correct me if I'm wrong, but it sounds like, Serhii, you're basically telling us, yeah, think about it and then see if it fits onto something that's well understood. And then if it doesn't, then yeah, you may have to go and do something a little different.
Well, let me clarify what I meant. So basically, transfer learning and pre-trained models, it is a good thing. And they very often help engineers to build their models. But I think that it is a first thing to consider. So at the first glance, you need to look at your task, at your data, and try to build a model assuming that there are no ready solutions. So how you would do it if there was no pre-trained models?
Mhm.
And so if you have a clear vision of this model and you will be successful in implementing it, it will be much better than some standard solution based on pre-trained ResNet or something like that.
Follow-up question to some of the discussion. We're talking about the data, and I'm 100% on board with everything you said about how data is the most important thing, way more than the algorithm. And I agree. When we're talking about curated labeled data for image classification, just how critical is the quality and the accuracy of those labels? And how do you get them in the first place?
You mean get data or get quality?
The quality labels, if you're doing classification, how would you figure that out?
Well,
You make your kids do it.
Most of
I
them,
have some of those.
Amazon Turk. Yeah.
of course, I do not label data manually. It would take ages for me. So currently, if you have a question where to get a data and you have unlabeled images, you have such options as going to annotation service and just pay money for annotating them, or maybe like if there are models available which are very similar to this task and trained on related at least data, you could use something like domain adaptation and pseudo labeling techniques, and like label at least part of this data and then build some initial model using this part of data. And after that, you can keep updating the rest of the data labels by improving this model. So as far as I know, this approach is called active learning, something like that.
Mhm.
And personally, I haven't faced with such task, but I know that developers are using it and it helps to label the images.
Yeah, like using a Siamese network where you're saying, hey, I have a ground truth, and then I have another model I'm trying to figure out how well can it actually predict what this other one I know is the correct one, and then start adapting that by passing in new things and saying, almost auto-classifying and auto-labeling. Yeah, those are complex, but they're super cool, and I've only seen them implemented correctly once by visually looking at the code, but yeah, they're really cool.
Yeah, I also heard about such an approach when we use activation maps received from classification models in order to find where the objects are and get bounded boxes, like rough bounded boxes. But again, it's only like a theoretical paper, and personally, I haven't faced with applying this approach in practice. But it sounds very interesting to me.
Yep. I want to go back to, though, you've mentioned that you may want to just start from scratch, right? With no pre-trained data. What algorithms do you use there? Like if you have data, maybe it's labeled. Yeah. What are you building from with that, right? What's your approach?
It's a very general question, but I can just tell about example from my experience.
Story time. I'll get popcorn.
So I participated in a project where we were building a biometric verification system, and one of this system consisted of multiple parts. One of this part was anti-spoofing, face anti-spoofing, and so the idea behind my model, which I decided to create, was that we have two images. First images is just regular images with a face, and second images is face after lighting on the screen. So we show a white screen, and we have like a reflection on the face. And like having such kind of data, I had idea in mind that Siamese network can work in this case because we have two inputs. So I decided to build this model from scratch, and I got pretty good results.
So the actual detection of the fraudulent activity was if somebody's holding up a piece of paper, it'll reflect and wash itself out more so than a natural fit. That's genius, man. So I read the blog post that you did on that, and I was like, man, I really want to see, because you didn't go into the details of that. And I was like, I want to know how this is built. But yeah, it's super cool. But I also read another blog post that you did about the driver's license verification, about that small image. And I guess it was maybe part of this project where you were trying to see, is this person who they say they are? And was that another stage in this validation?
Yeah. So that was part of this project. And well, it's actually what you're talking about is about finding the face on a document and doing a face recognition. And it sounds pretty straightforward to implement. But the problem is the quality of the images, because usually quality of images with driver licenses, they are very bad, because driver licenses, they have some spotlights, they are often dirty, they are very old, and like
I don't know. Mine looks just like me.
So you're the one.
During working on this task, I saw many very bad images with driver licenses, and that was a problem. But from the technical perspective, it's only a face recognition.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
But from the image pre-processing, when you're taking something of ultra low resolution or there's contrast issues, do you do pre-processing? Projects that I've done in the past where we had issues like this, I'd say 95% of all the work was in image pre-processing, where you're fixing, image artifact issues, or, hey, somebody took this picture with a digital camera that was probably manufactured in 1991 and it's 2014, and you're like, how is this so bad? Nobody's face is magenta. So just fixing that so the CNN doesn't get confused by some tones or some element of that. What sort of processing did you have to do, and how did you think through that process?
Well, to be honest, we tried to do such pre-processing, many different filters applied to images. But at the end of the day, we decided to go another way. We added image quality assessment model, and we just filtered out all bad images.
So you took the engineer approach. I approve. Yeah, that's good. Particularly in training data, because you're going to be polluting the model if you're throwing garbage data into it. And at classification time, you just want to make a best guess. I mean, that's all AI is. My best guess of what this is. Yeah, cool.
Yeah, if I may, I'm curious about the paper you were discussing in the beginning. We're looking at for the video processing. As far as we've been talking about image processing, and I'd be curious, how does the game change when you start processing live video or streaming video? Is it same types of algorithms, methods? How is that different?
Well, just let me describe the approaches which are possible to do, and I think that when I tell you about it, you will understand what is a game changer. So I see two possible ways to do the video processing. First way is naive serial processing, when you do the operations sequentially for each frame. And second approach is concurrent pipeline. And
quickly, when you say operations, you mean you're doing facial recognition or bounding box detection, things like that, or is that data cleanup, like in real time image cleanup, or all of the above?
I mean all of the above. So after you got a frame from the decoding, you need to do a bunch of operation. It may be pre-processing, neural network inference, post-processing, maybe some other stuff, maybe some filtering to improve the quality, and so on. So all these operations are done sequentially when we talk about serial processing. And so it looks like the simplest solution, and very often simplest solution is the best, but not in this case. Because first of all, time for processing an entire video equals the sum of time consumed by each such operation multiplied by the number of frames to process, and it is way too slow. And secondly, with such approach of serial processing, parallelism of your hardware is not utilized as it could be. So if you have multiple GPU, edge computing boards such as Intel Myriad, or even just CPU with multiple cores, or some combination of the above-mentioned devices, all this become useless in case if you do sequential processing. And I will try to describe why. So imagine that you are doing neural network inference, and after it post-processing, let's say some heavy post-processing which takes some time. And after neural network inference is done on GPU, you start doing post-processing, and this time during post-processing, GPU is waiting, so it is idling because it will start working on next iteration. And here's the question: why not to use GPU immediately? And here where pipeline approach can help. And so once the inference is done, it is immediately starts takes a next frame as input and start inferencing there. And it is possible because these two components of the pipeline work in two different threads. And so in this approach, the total FPS is defined by the bottleneck. And usually bottleneck is a neural network because assuming that we are developing AI-powered solution, probably we will have it there. And for understanding what is the bottleneck, it makes sense to measure the time consumed by this operation. But basically, what I mean by saying all this,
basically, it sounds like the big difference is video has so much data and it's in real time, and it becomes a matter of managing the computing resources you are at hand and kind of juggling so to make sure everything is busy, even though there's maybe three things to do. If you do A and then B and then C and then start over, you're not going to get full efficiency because machine A might be waiting for machine component C to be done. So to make sure you use your hardware, you're needing to make sure every component is computing. So you need to manage multiple frames being done at once at different stages. So your hardware, all your resources need to be firing at all times.
Yeah, you described it correctly. And only after introducing pipeline architecture to video processing, we can really use all available resources in an efficient way.
So if we needed to handle temporal relationships between video frames, we're trying to upscale a video, and we need to make sure that we're anisotropic filtering, for instance, between frames is smoother. I know that we see that with some of the older movies that people are doing. Oh, we're going to do an HD upgrade of this movie. And then the fans see it and they're like, oh, it's too smooth. It doesn't look like it does on film. So when you're handling like the temporal nature, frame 1 to frame 2 to frame 3 to frame 4, and there's a relationship between frame 1 and 2 in a temporal sense. If you're going to be doing effectively hyper-threading or thread pool processing, how would you handle that? And what sort of interface would you have to a buffer to make sure that you have correct ordering and referencing on priors for the current frame?
That's a good question. And actually, in my projects, I did exactly this, what you described. So we had a frame buffer, and we do not start processing from the first frame, but we wait for some time, some number of frames, in order to fill our frame buffer, and only after this we start processing because we see the context, we see the frames from the past and from the future, and we can build some algorithm which will decide what to do in the middle frame. So, and in particular, I applied this approach for interpolating the bounding boxes. If you decided to skip some frames, let's say in order to improve the performance and make it faster, because it is not necessarily to run object detection model on each frame. We can skip some frames and do it each second frame. And if you do it, you need to interpolate frames in between. And this is where this logic with frame buffer really helps.
So you just do persistence of where the bounding box is on interpolation between the states of the selections. That's genius, man. Definitely wanted to get you to that path, because it's kind of what, based on some of the blogs that I read of yours, I was like, I bet this guy is doing this. I just wanted to make sure it was on the podcast so people heard about it, because that is a genius implementation of how to handle this by lowering the pressure on your hardware, but still getting the same accuracy and performance. And that's what we should be doing as applied ML practitioners, is think about it as an engineer would. How can I reduce the cost of executing this while still maintaining the accuracy? And what you just explained hopefully gives everybody an idea into the mindset of a true engineer implementing something for an AI system. So great answer.
I was really curious about one aspect, because in video games we need to do this kind of parallel processing. Pipelining is a big deal. And I was curious. You mentioned edge versus cloud computing, and some parts can be suitable on the edge portion and some back in the cloud. Were you able to actually mix them up? Because that sounds like a really good pipelining challenge, to schedule some edge, then to the cloud, then back to the device. Or is that not feasible?
I think that mixed approach is possible, and moreover, it is mixed very often. So, assuming that video processing consists of multiple building blocks, which we already mentioned, so it can be decoding, preprocessing, inference, and other stuff. So we have these building blocks, and we can run some part of them on the edge and do the rest on the cloud. And this will address maintenance issues at some point. So imagine that you have multiple devices on the edge, and you have installed your system on these devices. And while going through development cycles, you need to think about updating all of them, because you will probably improve your system, add new features, change something. And it is not very convenient to update all devices all the time. And in the meantime, like an alternative approach is to run only some part of your models on the edge. So for example, you can run object detection model there, get raw bounding boxes, send them to the host. And in this case, business logic and post-processing can be modified much more easily because it is done on the cloud side. And just for example, we may have a camera with built-in face detection and recognition system mounted directly to the camera hardware. And while used, it gives only a final result, person identity. From the user perspective, it is functional, but from the development, it is not flexible. And another option is a camera which run a detection model, sends results to the host, and then we have a business logic or post-processing algorithm which does the rest. And in the first case, this camera device is ready to use a module, fully functional, but not flexible. And in the second case, our edge device is half-baked module, which is basically a source of information. And in my opinion, it is like a bit flexible solution than fully edge computing or fully cloud computing. But it is something in between.
Great. Yeah. Very interesting. Is there anything that exists out there, like out-of-the-box solutions to what I feel is a management like pipeline, like scheduling problem to, do some edge back to cloud, back to edge, and even on the edge device, I assume, manage each step in parallel or not?
Oh, well, basically the answer is yes. Indeed, there are options which provide architecture for pipelining. However, usually it is a low-level API which with their pros and cons, and sometimes they are maybe too obligating. So I would like to mention here GStreamer framework. It is media processing framework which is successfully applied in many applications, and it is based on multi-threaded pipeline, which we mentioned before. And as far as I know, FFmpeg framework also allows building a custom filter inside its pipeline, and even with a neural network. Personally, I have never tried it, but I know that it's possible. And the next item here, which I'd like to mention, is GAPI module in OpenCV framework. So although it is in the early stage of development, but it looks really interesting because they claim to provide a graph-based optimization of the entire algorithm, not only neural network as part of it, but the entire algorithm, including frame decoding, preprocessing, inference, and other stuff. So all operations which you do with the image, they are compiled into a graph, and this graph is optimized depending on the hardware, like different hardware which this operation use. And for me, it looks pretty much interesting. However, like despite the fact that there are existing out-of-the-box solutions, developing the pipeline on our own without any frameworks is also a good option, because in such a way you get absolute control and flexibility. But like disadvantage of this approach is that it may be very difficult or challenging to develop in such a way that it is your pipeline is responsible to changes of configuration. Let's say you may decide to change the backend device on the fly or change the output destination, and it is tricky to develop such pipeline which can update itself accordingly. But personally, I tend to go for this option because for me it leaves more space for experimenting and research.
Makes sense. Thanks.
All right. Well, we're kind of getting toward the end of our time. Is there anything that we missed that's critical to mention before we head into our picks?
Hey, folks, I don't know if you've noticed, but I've been working a lot on figuring out how to help people become the most valuable developers on their teams or becoming the top 5% of developers in the field. If you're looking to level up, figure out how to contribute more, get the career you want, get the career that you want that will support the lifestyle you want, then you should check out the Most Valuable Dev Summit. I've invited some of my friends across the community, people that you've heard of, people that have worked on systems that you use on a daily basis, people who have invented new ways of doing things over the years in programming, and I've asked them one question, and that question is, how do you become a top 5% developer? How do you become 1 in 20 of the best developers out there? And so we're going to go ahead and have that conversation with them in interviews on the Most Valuable Dev Summit, and you can find that at summit.mostvaluable.dev.
All right. Let's go ahead and do some picks. Now, we have 2 new panelists. You've both been guests, so you've done picks in the past, but I'm just going to explain it just for everyone's benefit. It's just shout outs about stuff that we're enjoying, stuff that we like. It can be books, can be movies, can be technical, can be non-technical.
We can pick movies?
Oh, yeah. Anything you want. We try and stay away from the political just because we're kind of in a place where people are unhappy with each other over stuff like that. But yeah, just kind of whatever you want. I'm going to go ahead and throw a few of them out. Now, one thing that I think I've been picking for the last few weeks, I'm still on this kick with, is a book called Who Not How. It's kind of changing the way that I'm running the podcast network. I've been trying to pull more people in to take on certain tasks within the podcast network, involve more people in some of the things that I have going on, just so that I don't have to be the person that's kind of the point person on everything. And so that I can go and I can serve more people, right? I could do the things that I'm really good at instead of trying to do all the things, whether I'm good at them or not. And so I've really, really been enjoying that book, and it's just really made me think. Over the last few weeks, another thing that I've picked up is, and I don't know if they do this everywhere, I'm assuming they do, is I joined a master's swim team. And master's is for adults, so it's 18 plus. Now, I swam in high school, but it's been more than 20 years since I was swimming on a regular basis in the pool with a coach telling me what I was doing wrong and all that stuff. And it's been kicking my butt. But I have really, really enjoyed being back in the pool. So I'm going to pick that. And speaking of having something that I forgot the term that you all were using. And, we've talked about it on the show before, but having something that's been trained for one thing and then you use it for another. What's the term for that?
Transfer
Transfer learning. Yeah. So I've been running marathons, right? I was supposed to run a marathon this Saturday, and I wound up sick on Friday. And so I couldn't run it. I actually contacted the marathon and they deferred my registration till next year. Yeah. Transfer learning doesn't work from marathon running to swimming laps. Just so that you're aware, right? So I was in okay shape for running. I was in terrible shape for swimming. It just doesn't, transfer and learning doesn't work there. My technique was pretty good in the pool, but I was sorely out of shape. And so I've been pretty sore this week, but I love it. So if you're looking for a good way to just get a full body workout, go see if your local rec center has a master swim team. Might mean you're getting up at 5 a.m, but I think it's worth it. So I've been enjoying that as well. And then I'm going to pick 2 more books. I have an Audible account and I tend to listen to books. And then if I really enjoy the book, then I'll actually go buy a hardcover like I did with Who Not How. So I'm actually going through it again in hardcover. But these 2 books are books that were recommended to me by some friends of mine. And it's really kind of making me think about things in a different way as well. And they're kind of related. So for what it's worth, I'm going to pick them. The first one is As a Man Thinketh. I'm trying to remember the author's name, but it's an older book. Like the newer books, they kind of have a different structure to them where they kind of go, hey, here's the principle and here's a story and here's an illustration of where you might use it and blah, 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 right? The older books, like I'm trying to think like Think and Grow Rich or Win Friends and Influence People, they tend to be much more, here's the principle, here's how to use it, here's the next principle, here's how to use it, here's the next principle, here's how to use it. And that's kind of how this flows, right? So it's really, really dense information-wise, but it's terrific. So As a Man Thinketh. And then the other book is Psycho-Cybernetics by Maxwell Maltz. And it's been rewritten. I got the updated and revised version. And I can't remember. I think Dan Kennedy picked up, like he bought the rights to revise it and stuff. And it's kind of been rewritten with Maxwell Maltz's voice, but it's kind of modern age stuff, right? And so anyway, I'm really, really enjoying it. Dr. Maltz died in like 1973 or something, but they kind of revised it so that it talks about having a cell phone and having that affect things. But they're both about visualizing what you want and visualizing who you want to become. And so As a Man Thinketh, the main focus is what you think about is what you become. And then Psycho-Cybernetics is literally visualizing what you want, visualizing the thing that you want to materialize, and then focusing on what you have to do to get there. And just by visualizing it, you're more likely to have it happen. So I'll pick those. We'll put links in. If you put the links in the chat, they wind up in the show notes. So that's the best way to do that. And yeah, those are my picks. Francois, why don't you go ahead and go next?
Yeah, that sounds like that. If you don't know where you're going, you're going to end up somewhere else. What was that?
Mm-hmm.
That baseball philosopher guy, quote unquote philosopher. No, that's good. For my part, I'm sticking with kind of my latest pick, which was more, I'm all about workflow, not reinventing the wheel, using computers to serve us. We're the masters. So anything that can be automated I mentioned feature tools last time for automated feature engineering. That's always great to do, trying to see if there's something that can be extracted out of the data. Another thing I ran into is on my personal workflow, sometimes I'm trying out model after model, changing parameters, changing the way the data flow is on a given project, and then it all makes sense. And then I save things, underscore V1, V2, V3, V4, and I have all these experiments and things, and I go back to there, 2 weeks later, I'm like, what was that crazy thing I tried that was kind of, that did this kind of feature that could have been insightful, and I have no idea. And I look at all my files and trying to figure out history. So I've started looking into, or I discovered automated experiment tracking and that kind of stuff, where everything you ever do is automatically logged. So you always know the exact code that was run, all of the results, and that's done transparently. So far, I'm working with Comet.ml. And that's one of them. I know there's multiple out there, but just something to be on the lookout for if you're looking to enhance your workflow. There's probably a tool or a library out there to make your life easier. And once in a while, it's always, I think, good, good thing to just maybe spend half an hour to an hour just to say, hey, like, is there anything, or even with your own, creating your own functions, because things you keep repeating over and over, you can probably in the long run save a lot of time. So there's automated experiment tracking, feature engineering, and so it's my tidbit for the day.
I love that. I have so many thinks about that, but I'm gonna let Ben share his picks instead.
Yeah, from like the past couple of weeks, getting more involved with the MLOps community. Really great group of people there, and very interesting, pointed discussions. Some flame wars, but they're professional. So if you haven't heard of it, check it out. It's a great Slack community, several thousand members now, run by Demetrius Brinkman. And it's just a great place to go and learn and contribute and help other ML professionals out in pretty much any question that they're having. And hopefully you can bring some knowledge to the table. On the book front, two things. One of my colleagues, Databricks, Lee Hao-Yi, wrote another book, and it's pretty great. It's hands-on Scala programming. It's sort of a practical guide to Scala development. I'm one of those weirdos in the ML world that does both Python and Scala in production. But the way that he approaches it isn't just for the Scala language. It also teaches pretty thorough software development practices and how to think through a problem and write the code for it in the most simple, maintainable, and extendable manner. The guy's a legend in the community. He contributes to the core language of Scala. So definitely check that out if you're interested in improving your software development practices, which is, I'd say, very critical in the data science community. And then my other pick is something that makes me giggle, which is the latest book by David Thorne. Check it out if you want to laugh. A little bit of dark Australian humor, but super funny. The guy is ridiculous. Those are my picks.
Nice. I think your picks made my nerd cred go cry in the corner. So, all right. Serhii, what are your picks?
Well, to be honest, I wasn't ready for this question, but I would recommend one book, which is called Atomic Habits by James Clear. Probably heard about it. It's like, I really enjoy it while reading it because it is written in really clear manner. Just you understand everything on each page, and like it's easy to read, and it helps you to improve your everyday life with creating good habits and getting rid of some bad habits. It may sound odd, but I really recommend this book.
Awesome. And if people want to connect with you online, where do they find you?
Oh, you can find me on LinkedIn network. So I believe that if you type my name there, it will be easy, but I assume that a link will be also provided somewhere.
Mm-hmm. Yep, we can get a link in for LinkedIn.
Yeah, and if you search your name, actually, you dominate the top 50 Google results. So yeah, you're easy to find, man.
All right, good deal. Well, let's go ahead and wrap up here. Thanks for coming. This was an awesome conversation. And
thank you for inviting me. I hope that it was helpful. And I was excited to share the highlights from my experience.
Oh, yeah, absolutely. All right. Well, till next time, folks, max out.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.